Hello guys, and welcome to this new video in which we are going to be talking about nothing else but pointers in C. So the easiest way to think about a pointer is that it is simply a variable that doesn't store a direct or a normal value like other variables, but instead it is a variable that stores the memory address of another variable. Now let's understand this better with the help of a quick example. Let's say I have a variable in my program called h, which is going to be an integer, and I will call h and set it to 25. Now we can also print the value of this h variable using our printf function. And if you run this program, of course, it is going to display h equals 25. So we can see the output says h equals 25. So that is something very normal which we have done. We have simply declared a variable, assigned it a value, and then printed the value of that variable. Now let's see how a pointer is going to be different from this regular h variable. So I will come below my h declaration and I want to declare a new variable which is going to be a pointer or a variable that points to the value of h. So before we talk about that, we need to first of all know what we mean by a memory address or location. As you can see, this variable h equals 25. 25 is the value of this variable, but if we know what variables actually represent, a variable is a memory location in our computer which is given a name and stores a value. So this variable, it has the name h and it has the value 25, but this 25 is actually stored somewhere in our memory or in the memory of our computer, which is what we know as, or we call, the memory address or location. So with the pointer, we are going to try to access the memory address of this variable instead of the actual value 25 that the variable has. So in order to do that, I will declare a pointer. The pointer is going to be of type int because we are trying to access the address of an integer, so the pointer should also have integer as data type, and I'm going to call this hptr. So by convention, when we want to declare a pointer, it generally has the name of the variable which we want to point to, and then followed by the suffix ptr, which means pointer. So we mean h pointer by writing hptr, and I'm going to set this equal to h. When we say h, we mean the h which is the variable we already declared. But now simply writing this int hptr equals h, what this does is it's going to simply take the value of h25 and assign to this new variable which is hptr, but that is not what we want to do. We want to actually make hptr a pointer in order to access the memory address or location of h. So in order to specify that hptr is a pointer, after our int here, our data type, we add an asterisk after this data type int. So when we write int followed by the asterisk, we are specifying that this integer variable is not a regular variable, but it is actually a pointer. And this asterisk means we are not going to be storing regular integers, but we are going to be storing memory addresses instead. But the data type should still be int because we are storing a memory address with the asterisk, but it is the memory address of an integer, so the data type should still be int, or whatever the data type of the variable whose address we want to store is. And now when we write int asterisk hptr and we set it to h, we have already set this integer is a pointer because of the asterisk, so we can no longer assign it a regular integer value like 25, which is the value of h. So in order to make sure that we are rather accessing the memory location of this h variable instead of the actual value, we use a symbol before the h variable name, which is going to be the ampersand symbol. So now we are saying int hptr equals h with the ampersand before it. So this ampersand means we are accessing the memory address of h, not just the h variable's value. So this is all we have to do in order to assign a memory address to a pointer variable. We make sure that we write the asterisk to indicate that this is going to be a pointer, and for the value we are assigning, it should be preceded by an ampersand to reference or access the memory address of this variable instead of accessing the variable's value itself. And now let's also print the value of this pointer. As I said, the value of the pointer is going to be the memory address of each variable. So I will copy this, my printf message, and I'm pasting it below. So instead of h, I want to print the h pointer, so I will say h pointer. And for the format specifier, we are going to change it from %d to %p. %p is a format specifier for pointer variables, and instead of the h variable, I want to print the hptr variable. So now let's run the program again, and we see h equals 25 while h pointer equals whatever this character is. This is the memory address. We can see that the memory address is different from the actual variable value. So this value we have in the h pointer here, it represents a memory location in our computer. And now one last thing I want us to see about pointers is, if you are given a pointer, or if you have a pointer like our hptr pointer which we have here, we can also use this pointer to access the value which is stored at this particular memory location. We know that the hptr is a memory address, but we can also access the variable value which is 25 that is stored on this particular memory address, and that is known as dereferencing a pointer. So let's see how to dereference the pointer. I'm going to print this printf message again, and I'm going to change my message here from h, I'm going to say value at pointer. And for the value at pointer, the format specifier is going to be a %d, not actually a %p, because I said %p is used to print the pointer itself or the memory address, while %d is used to print values. But I said here that we are trying to print the value on this particular pointer or on this particular address. So that is why we use %d, because it is going to return an integer value. And here, instead of h, I will say hptr. I will simply add the ptr at the end, which is going to display that long memory address we saw recently. But in order to specify that I don't want the memory address itself, but just the value which is stored at that address, I will add an asterisk in front of hptr name. So it is now asterisk hptr, which is going to return the integer value that is stored on this memory address. And that is why we use %d, because 25 was an integer. And now let's run this again. Now we see h equals 25, h pointer equals whatever this is, and value at pointer is 25, which is the same 25 that we had on our h variable. So when we use this asterisk, a common way of understanding what this means is that when we use the asterisk, this asterisk means we are trying to access the value at this variable or this pointer variable. So this means the value at hptr variable. And we can also even modify values of variables through the pointer. So before printing the value at the pointer here, or let me print this 2 times actually, but before the second printing, I'm going to try to access this variable using the pointer in order to modify its value. So I can say I want to access the value at hptr. I said when we use the asterisk, it means we are trying to modify or access the value at that pointer variable, not the memory address itself. So I will say value at hptr and set this to, instead of 25, let me put 19 now. And now when we will print the second time, we will see that the value of our h is changed to 19. So I will print the h again. We are going to see that the h is going to be changed from 25 to 19 now, and we have done all of that without writing the variable name h itself, but we have simply used the pointer that points to h in order to modify the value of the h. So let's run this, and we can now see, look at the 2 last results, h equals 19 now and value at pointer equals 19. So that is how we can use pointers in C programming. We have seen how to declare a pointer variable and assign it the memory address of another variable. We have also seen how to display memory addresses using pointers, and we have even seen how to use pointers to access and modify variable values.